Welcome to the Connect with Truesight webinar. During today's session, you'll be able to ask questions of our panelists. The question and answers, as well as the webinar recording, will be posted on our YouTube channel and communities a week from today's broadcast. Today's topic is TSSA, Troubleshooting Best Practices for Redhat Patch Management, and Rohit Sharma will take us through this content. Over to you, Rohit.
Thank you, Greg, and hello everyone. I am Rohit Sharma and I am a Senior Technical Support Analyst. I have been with BMC Customer Support Organization supporting Truesight Server Automation, formerly known as BladeLogic Server Automation or BSA, for more than 6 years. In this webinar, we will talk about the process of patching Red Hat Linux servers in TSSA. We will talk about troubleshooting various errors that may occur either in patch catalog update job, patch analysis job, or a patch remediation job. First of all, let's understand what is TSSA Red Hat Linux Patch Management. Truesight Server Automation enables system administrators to automate the process of patch management, which is otherwise complex and time consuming. TSSA holistically manages the patch process, helps administrators to automate the creation of a local patch repository, run analysis to identify missing patches, and install the missing patches using automated patch deploy jobs to meet organizational standards. These are the tasks within TSSA patch management. The first task is the patch catalog creation. Patches are downloaded from Red Hat on a local patch repository. Identification of missing patches. A patch analysis job is executed in this step to identify missing patches across servers. Patch remediation. Missing patches identified in the patch analysis job are installed in this step. The last step is to rerun a patch analysis to ensure that the server is fully compliant and there are no missing patches on the server anymore. During the course of this webinar, we'll speak about all these tasks. I will start with the patch catalog creation via patch catalog update job. Now, before creating a catalog update job, we need to ensure that these prerequisites are met. We will need a repository server with ample disk space and a RSCD agent installed. Patches are downloaded and stored on the repository server. For Red Hat Linux patching, we need the repository server to have the access to the internet. The repository server must have a repo sync, a create repo, Python-URL grabber, and bzip to install on the servers. The high-level steps are: ensure prerequisites are met, register the repository server with Red Hat, import Red Hat certificates in TSSA, run the catalog update job to create the patch catalog. We will now see how to create a patch catalog in TSSA. The first step to create a patch catalog is to register a server with Red Hat. I have now logged into my repo server and I will show you the commands that are typically used for the registration. To register a server, first run this command: subscription manager space register. I'll run this command here. Now it asks for a username and password. I'll provide my Red Hat username and password. So the server is registered now. So once the server is registered, we need to attach a subscription to the server. But before we do that, we need to check what are the available subscriptions with the IT from which we have registered this server. Now to check that, we use the following command: subscription manager list -- available. I'll run this command here. You will see various pool IDs here, and based on the product you can select an appropriate pool ID and run the following command to attach the pool ID. So I'll show you what is the command that we can run to attach the pool ID. So this is the pool ID that I'm going to use here, and I'll run this command to attach the pool ID. So the pool ID is attached now. Now if you want to see what are the pool IDs that are attached, or what are the subscriptions that are attached to the server, we can run this command: subscription-manager space list -- consumed, and it will show you the registrations on the servers. So as we can see, I've run this consumed command and it has listed down the pool ID that I have that I have attached to this server. Now once the subscriptions are attached, you'll see that the new certificates are downloaded under the etc pki hyphen etc pki entitlements directory. I'll show you that. So these are the two certificates that are downloaded. The two certificates are SSL client key, the one with hyphen key, and the SSL client certificate, the one that is without the key. Now there is a third certificate as well, which is usually inside etc RHSM CA. I'll list that directory as well. Now this certificate is called as SSL CA certificate, and it is usually inside, as I said, etc RHSM CA folder, and the name is redhat-uep.pem. Now once these certificates are downloaded, we need to import the certificates in TSSA console. Now let's log into the TSSA console. Now we can see that this is the TSSA console, and to import the certificates, we'll go to configuration, patch global configuration. We'll click on Red Hat here and subscription certs. So as you can see, these are the certificates and these are supposed to be imported here. And once the certificates are imported, we are good to create a patch catalog. So let's see how do we do that. So I'll hit cancel here. I'll expand the depot workspace, click on any folder, new, patch catalog, and Red Hat patch catalog here. So it has opened a wizard. Let's put the details here. Let's say Red Hat 8 sample, and in the repository location, I'll specify the name of the server, where name and a directory of a server where I'm going to download the patches. Find the server here. So I'll just select a directory. So I'll just relate Apollo here, this, and I'm going to select a filter for this demonstration. I'll select, let's say, Red Hat here, Red Hat 8. I'll expand this so that this is visible. Red Hat 8, I'll not select any child channels right now. Hit OK. So for the demonstration, I'm using an online, the online mode. Now I'll hit the job options here. So you can see that these job options are same for as we have for Windows and other operating systems. These are notification, depot object options, job properties, and permission. These are same for the patch catalog for every other operating system as well. So I'll hit OK. So this is how you create a patch catalog. Now a patch catalog can take a lot of time to run, so in the interest of time, I'll not run this job. I'll show you one of the jobs that I have already executed. So I'll hit cancel here, expand the webinar, open rel 8. So this is rel 8 patch catalog. I'll go to results tab, and this is a successful catalog update job. So I'll hit on run here. As we can see that the erratas and RPMs are added. Now this is a new patch catalog, so none of the erratas or RPMs are updated, but as in when you run a catalog update job, you'll see that some of the erratas and RPMs are listed in this updated column as well. So this is all about a successful catalog update job. Now I wanted to show you what are the files that gets downloaded to the repo server once a catalog gets updated. So we'll just log into the repo server and see what are the files that are downloaded with when a catalog update job is executed. So this is the repository server. I have already cd'd to the directory which I specified in the job. I'll just run ls-la and more. So you can see these are all the RPMs. So they were around 6,000 RPMs, and these are the RPMs which are downloaded in the folder. I'll not list it all. I'll remove all the RPMs from the listing and show you what are the other files. So I'll use a grep-v RPM. Now, as you can see, these are the files apart from the RPM files. These are the three certificates. We usually rename them RH-SSL CA cert, RH-SSL client cert, and RH-SSL client key. So these are the certificates that were imported in PGC. They are copied, patch global configuration, and they are copied here. We create a custom yum.conf as well. Then there is a yum underscore redhat underscore catalog.repo, which contains the channel details. So this is a Red Hat 8 catalog, so it contains the CD and URL, label, and the path of certificates here. And apart from this, there is a script that we copy, which is the yum underscore metadata underscore generator.sh. Now, when a catalog update job is executed, to download the RPM, we run the reposing utility. So that reposing utility is being called by yum metadata generator.sh, and the log is written to this file yum underscore metadata generator.log. So if you do a tail-f here, you see that that the reposing was successful, and it has downloaded everything. So this is how a successful yum metadata generator log would look like, and if there are some failures while downloading, it will be listed here. Then we have this catalog underscore 2011400. So it's usually catalog underscore a random number, and let's see what are the files that are listed here. So I'll run a ls-la command. I've cded to the folder and run this command. So this is a list file. The important thing for us to look here is the create repo wrapper.sh. Now once the yum metadata generator.sh is executed, it runs reposing to download all the RPMs. We create the metadata for those RPMs. Now that is being created by this create repo wrapper.sh script, and the log is written here. So if we do a tail-f here, we can see that the successful script would be, the output of a successful run would be like this. So it has listed that all the RPMs, it was able to create the metadata successfully. The repository creation was successful. Now that repository creation, the metadata is usually in this folder. I'll show you the contents of this folder as well. So it will list all the 6,000 or something RPMs that are downloaded. They are soft linked in this folder. So the file that I wanted to show you was this repodata.tar.gz. This is the actual metadata file. So when we run a patch analysis job, this is the file that gets copied on the target server, and we run the yum. So the yum command that we run in the analysis to determine the missing patches, it uses this file which is copied from the repository server. So in case there are any problems with the catalog update job, in case we see that there are any errors while updating the patch catalog, the logs that we generally ask for are the application server logs and the job run logs, which are the obvious logs. Apart from that, from the repository server itself, yum metadata generator.log can be very useful in case there is some problem with reposing, or the create repo wrapper.sh log as well, which is useful in case there is some problem while creating the metadata. We can also check the RSCD log from the repository server. So these are all the logs that we usually ask for, and this is, as we can see, this is how the directory structure look like. So in the next slides, we will see some of the troubleshooting scenarios, and so yeah, let's get started. We will now see what to do when a Red Hat Linux patch catalog update job fails with 403 forbidden error. I have now logged into the console, and we can see that there is a patch catalog update job which has failed. Now let's see what is the error here. I'll do a show log. So this is the job run log, and the error that we see here is blpat1225. Failed to run reposing on repo directory, HTTP error occurred, possible remediation step, please check the Red Hat certificates provided in patch global configuration. For more details, check the yum metadata generator.log, and it is given the channel name as well. So it clearly says that there is a problem with the entitlement certificates that we have imported in the patch global configuration, and it is asking us to check the yum underscore metadata underscore generator dot log, which is generated on the repo server. So let's log into the repo server and see what is there in the log file. So I'll log into the repo server here. It's my repo server. I have already cd to the directory, and let's see what is there in the yum metadata generator.log file. Now I'll do a tail -f, and yeah, as we can see, here is the 403 error here. HTTPS error occurred 403 forbidden. So this error is usually due to the entitlement certificates. Now a subscription entitlement certificates can be revoked anytime by Red Hat to ensure its accuracy. Now since the certificate is used to grant access to the products on CDN, to guarantee that the certificate reflects the current changes, sometimes Red Hat automatically marks it as dirty, which means that the certificates needs to be regenerated and re-downloaded on the client. Now, please note that Red Hat can mark this certificate as dirty anytime. So, I mean, even if there are no changes made on this account. So, I mean, 403 usually means that there is a bad certificate that you are using. Now, I told you earlier that whatever the certificates that we we are using, that certificate, they are copied on the repo server from the patch global configuration, and these are the three certificates. And this is the repo file which contains I'm sorry, this is yum underscore redhat underscore catalog dot repo file, which contains the list of the CDN channels from which the RPMs are supposed to be downloaded. And this is, as we can see, it has listed rel7-server-RPMs as the label, and this is the CDN URL. So we'll just try to run a repo sync command manually, just to see if we can simulate the error. So the command that yum underscore metadata underscore generator dot sh script calls the repo sync command, it's repo sync -a, which is the architecture. So it's x86 underscore 64. Then we'll have to specify the yum.conf, and it's a custom yum.conf that is created inside the repository directory, and -r is the channel label. Now, a point to note here is that for Red Hat 6 and 7, I am using this -r as the repo option as a tag before specifying the label. For Red Hat 8, this -r doesn't work. It is --repo. So that's the only thing that is changed in the command for rel 6.7 versus Red Hat 8. Instead of this -r, we have to use --repo. So I'll just run this command and see if I am able to simulate the repo sync error outside of TSSA catalog update job as well. Yeah, so you can see that even if I am running a repo sync command manually from the server directly, I am getting this CDN error here. I'm sorry, the 403 forbidden error. Now this proves that there is definitely a problem with the certificates that we have imported in the patch global configuration. So the solution in this case is to re-download those certificates and re-add those in patch global configuration. Now we have already seen how to do that, so I'm not going to show that in the demo. As in the previous demo we saw how to download the certificates. The same steps have to be used here as well. So this is how you troubleshoot and fix the 403 forbidden error. Let's move on to the next problem. We are now going to see what to do when a patch catalog update job completes with no errors, but not all the patches which are expected to be present in the patch catalog are there. Now, Red Hat distributes RPM across multiple channels. So if a catalog update job is successful and an expected RPM is not downloaded, it means that the RPM is not a part of the selected channel and you have to add the correct child channel. Now let us see how to add a child channel in the existing catalog update job, and we'll now move to the demo. So I've now logged into the console, and you can see I'm trying to search for this RPM Babel trace inside my rel 7 patch catalog, and I'm not able to find it inside RPMs. So as I said earlier, that if the catalog update job is successful and you are not seeing an expected RPM present in the patch catalog, it means that one of the child channels that the RPM belongs to has not been selected while doing the catalog update job. Now, first of all, let's see how to just select a child channel. So this is the catalog update job that I've opened here. So I'll just click on the selected filters. I'm not going to add a new filter. I'm going to add a child channel to the existing filter. So I'll click edit here. So this is the window. I'll just expand it a bit. So this is where you select the actual channel, and this is where you select the child channel. So you can just click on whatever. I mean, there are some default child channels here that we have provided. So what you can do is you can find the appropriate child channels, click it, and just click on the plus sign and just select it, and once you hit OK, it will be added in the patch catalog. Now it is very important to figure out what, I mean, that if, let's say, if a certain RPM is missing, you'll first, before adding the child channel, you'll have to figure out what is the correct child channel for that RPM. Now so as we see, the RPM that I selected was Babel trace. So what I did was I logged into access.redhat.com. I searched for this RPM here. I search for the RPM and see, we can see that this RPM, the search result says that it is for Redhat Ceph Storage 2.0. So I open this access page here, and it says that this is the errata where which it belongs to, and this is a Redhat Ceph Storage 2.0 channel which provides this particular RPM. Now it is possible that I mean, even though we have added some of the default channels here, I mean some of the most common child channels in the filter list, we have not added all the child channels, but it is possible for you to add a new child channel to the existing filter list as and when necessary. Now we have identified this as a Redhat Ceph storage channel. Now let's suppose this particular channel, when you're searching in the child channel list here, this Ceph storage is not present here. I mean, it is not a default channel that we add here. So let's see if you want to add a new channel, how to do that. So if you, I mean, the very first thing that we need to do is we need to log into to a repository server which has registered and subscribed with Redhat. So I have now logged into my repository server, which is subscribed to Red Hat. So the first command that I'm going to run here is rct space cat -cert and the path to the SSL client cert file. Now the SSL client cert file, as we already saw, it is downloaded inside etc PKI entitlement. So let us run this command. So when we run this command, it will give us this huge list of all the channels which are, I mean, all the child channels and which are available from Red Hat. So the next thing that we'll have to do is we'll have to use this file and make sure that we add this channel in our filter list. So the very first thing that I'll do is I will copy this to the contents to a text file, so that I mean, we can see what are the channels that I'm looking for. So I've already done that. I have copied this the contents of this file to this text file, and this is the I mean, this is how the output looks like. So this is the content of the Ceph storage tools channel that I'm looking for. As you can see, the type here is yum. The name is Red Hat Ceph Storage Tools 2 for Red Hat Enterprise Linux. This is the vendor Red Hat, and this is the URL here. I mean, this is the GPG here. It is enabled false expiry date. This is the expired time in seconds. This is the tag, and this is the architecture. So this is a basic information which is provided by Red Hat. So we'll use this information to edit it in one of the XML files. Now the XML file that I am going to use here is will be the patch global will be from the patch global configuration. So I have to export the existing file, the existing filter file that we are using in the product right now. So to do that, I'll go to this Red Hat channel filter list, and I'll click on this export button here, and I'll select a server. This will list us the smart group, and I'll select a server where I want to download it. Now I have already downloaded the file and copied it on my desktop. So I'll open that, and this is how the channel file looks like, and these are the contents of the file. So if you can see, this is the content of the file, and these are all the tags that that are present here. So I'll have to make sure that I edit it in the correct format, and then save the file and re-add it there. So I've already done that. I'll show you how to do that here. So this is the file. So this is a sample tag that I have selected here. So this is the Red Hat channel. This is channel name, channel label, channel OS, channel architecture, URL, etc. Now this is the content that I've copied from the RCT command output. So these are all the details here. So I will put the name here. So the name I have copied, which is from here. The label has also been copied to the tag here, which is this is the channel label tag. The operating system I have used RHES 7. This is the architecture. Now if you see here, the the URL is this. I'll just copy it here. The URL is content dist rel server 7, and then there is this $release server and $base search. Now we have to edit these two parameters, release server and base search. Now for 7, this release server parameter will be 7 server. If it is 6, then it is going to be 6 server. So I have added it here. 7 and 7 server, and the base arc is the architecture. So since we are using it for x86 64, I have added the correct architecture here. Now this is how it will look like. Let's in fact let us just edit that as well. So x86 underscore 64 instead of base arc, and this is the 7 server. Yeah, now once you edit that, you have to append this cdn.redhat.com at the start of the URL here. So I'll do that, and that's our complete URL. So this is the URL that I have used here. Now I will just put this tag in my XML file here. So this is my XML file. I have put the tag here already. I'll show you how it looks like. So I have just put it where all the Red Hat 7 child channels are added. So there is no specified location. You can just put it anywhere. So there was a Red Hat Ceph Storage Tools 1.3. I have added it at the bottom. So make sure you are adding it where all the Red Hat 7 child channels are added. But the order is not necessary. You can add it anywhere, but make sure you add it next to the channel where next to the section where the Red Hat 7 child channels are added. So this is where I have added, and this is the content looks like. Now once what I'll do next is I'll save it, and I'll import this back to the patch global configuration, which I have already imported. To import this is the ellipsis button that you click, and it will bring up the window, bring up the smart group, the patch smart, the server smart group, and you can select the server where you have stored it, browse it to the location, and select it. Once you select it, click apply and OK. So once you do that, the new child channel will get added in the list here. So I'll just show you what you have to do here. You have to click on this channel, the edit sign. Let's just expand it, and as you can see that this Ceph Storage 2 is now added as one of my child channel. It is not there earlier by default, so I have just now added it for the demonstration. I'll just select it and click on the plus sign here. Now this is added by default. I'll remove it. I don't need it. So as you can see that I have so my base channel here is Red Hat Enterprise Linux 7, and I have added the Ceph Storage Tools child channel here. I'll hit OK, and I'll save the job here. And once you run the catalog update job after saving it, it will download the RPMs for all the all the RPMs for this particular child channel. So this is how you add a new child channel in in the filter list and create a patch catalog with additional RPMs from the child channel. We'll now, this concludes the demonstration part for the catalog update section. We'll now move towards the patch analysis section. So we will now see how to create a Red Hat Linux patch analysis job in TSSA. A patch analysis job identifies missing patches on target servers, and it also automates the process of determining which is the patch that is required across multiple servers. So let us now see how do we create a patch analysis job and learn more about it. So as you can see, I have already logged into the console, and I'll show you how to create a patch analysis job. So what I'll do is I'll do a right click on the sample folder, new patching job, and Red Hat Linux patching job. So I'll put a name here, let's say test job. So the folder is specified, the catalog, it has picked up a default catalog. I'll not change it for now, but you can change the catalog if you wish to. I'll hit next. Now these are the two options in which an analysis job is patch analysis job is executed: the update mode and the install mode. So the patching is usually done in update mode, where it scans for scans for the installed patches on the servers, and if the available update is present in the catalog or not, and it will scan for updates for installed patches only. The install mode is used in certain scenarios where you want to install a certain patch, whether or not an older version is installed on the server. So install mode usually requires an include list, but the patching is primarily done in the update mode. There is a section where you can customize the yum.conf. If you leave it as is, the default is used. There are these two options as well, include exclude options, which is by complete package name and by package name only. We will leave it to by complete package name for this demonstration. I'll talk more about this these options in some of the later troubleshooting sections. I'll leave it as is now, and I'll move further. There is an option to select include exclude list as well. You can select the list. I'll keep it as is for now. I'll hit next. This is for remediation. I'll not check it as of now. Hit next. This is the place where you can select a server. I'll not select anything right now. I'm just showing you the options here. This is the notification options. I'll leave it as blank. Execute job now. If I check it, as soon as I hit finish, the job will be started. And these are the options here. The properties, if you want to set the job in debug mode, this is the place where you want to set the job in debug. You have to set this value to true here. I'm sorry, yeah, it's this one. It's set to true, and hit next. And this is the access control list. So I'll not create the job, I'll leave it as is. I will show you one of the jobs that is already created. I'll hit cancel. So this is a sample job that I've already created. As we can see, the job status is failed. I'll expand it further. The analysis run, and show you that there are two successful targets here, and there is one target that got failed. Now, if you want to do, in the next demonstrations, we'll see that if we want to troubleshoot and analysis issues, we need some debug logs from the target servers, and sometimes we may need the application server logs or RSCD logs. So we can get all of these logs by just downloading a log package, and we can select select the targets the targets for which we want to collect the logs when we are downloading this log package. To do that, we just have to do a right click on run and select download log package. It will ask you to specify a location here, so I'll specify a location, C and temp. Let's say I'll select log package. I'll not download it, I'm just showing you how to download a log package, because the downloading can take time. So once the location is specified, you can select the servers here. From this drop down, you can select all failure, successful, or warnings. So based on your requirement, you can select the servers here, and once you hit OK after selecting the servers, it will download the log package. Now the log package download can take some time, so in the interest of time, I'll just show you the log package that I've already downloaded. I'll hit cancel here, and I'll just go back and show you how the log package looks like. So this is the log package. It downloads a zip file. I've extracted it, and these are the contents. The contents will be application server logs from all the application servers. It will contain the RSCD logs from the target servers, job run logs, and the job run log from the application server which ran the thread. Apart from that, there is a patch support zip file which contains the actual patching logs. So now when we extract it, we'll see that for I got the patch debug logs for two target servers, which are nothing but the yum logs. So let's see what are the files here. So you can see this repodata.tar.gz. This is the metadata file that gets copied on the server. The Linux analyzer script, which the script that we run to do the patch analysis. Then the yum analysis.result file. Whatever the results of analysis are stored in this file, as we can see. We'll talk about some of the details in upcoming demos. I'm just trying to show you what are the contents of this log package here. And there's a yum.conf. If there is any error, it will be listed here as well, the installed RPM. And these are all the files that are useful. So whenever we are troubleshooting any yum analysis, Redhat Patch Analysis issue, a log package is very useful. So this is how you collect a log package. We will now see how to troubleshoot some of the most common errors during a Red Hat Linux patch analysis job. The first error that we will talk about is the yum dry run failed error due to one or more packages. So I have now logged into the console, and we can see that this job has failed. So I'll just do a right click and see what is the reason of the failures with a show log. I'll hit show log. I'll drill down to the server name here. So this is the server test1.webinar.com, and as we can see here that the job has failed due to a yum dry run error, and it has a lot of RPMs. Now this error can be a little bit vague sometimes because it tells you that there is a yum dry run error due to a lot of problems, which lot of RPMs, which can be a bit difficult to understand. Now in case we want to troubleshoot this further, the first thing that we need to do is check the debug logs. So we'll check the debug logs by downloading the log package. So let's see what is there in the log package, and this is where I have downloaded the log package for problem 1. I have extracted it, and this is the patch support. Let's open the patch support, the server test1.webinar.com. So the first thing that I want to look is the yum analysis.res file, just to see what happened with the yum analysis. So this is, we can see here that it is reporting dependency resolutions for a lot of packages here, and it is recommending to use skip broken as well, which is not always a good options because it excludes. So if we use this option, the yum automatically excludes the patches for which the dependencies are not met. So I mean, it's not a best option to use. So this is how the yum analysis.result file looks like. Let's see what is there in the yum ERR file. So I'll open this. So this is the actual error here. So we can see that the error states package abrt-dbus, and it requires abrt-libs, and installed is this version. Now the second patch is abrt-addon xorg, and it also requires abrt-libs. So the trick in these scenarios is to identify a pattern. Now we can see that there are a lot of patches that are being listed here, but I mean the common patch here for all of these patches is abrt-libs. As we can see that everything is pointing towards the abrt-libs. So it's possible that there is some problem with abrt-libs. So we'll have to find out what if this patch is installed on the server or not, or what is the status of the patch on the repository, if this is there on the repository or not. So let's first log into the server and see what's the status of the patch on the server. So this is the server I have logged into. I've already executed this command rpm-qa grep-i abrt.libs, and this is the version of abrt-libs that is installed on the server. Now let's see. So the other thing that I want to see here is, because a lot of other patches are complaining about abrt-libs. So it's possible that this patch is a dependency of a lot of other patches, and that's why it is failing. So let's confirm what are the dependencies of this patch. In order to identify the dependencies, I'll run this command rpm-q-what requires and abrt-libs. So when I run this command, I see that there are these patches: abrt python, abrt-dbus, abrt-addon, kernel loops, and these are all the patches which which require abrt-libs as a dependency. Now, if you notice that all of these patches are listed in the error here. So, I mean, one possible scenario of the error here could be that when we are doing a yum analysis in an update mode, so it is trying to update the abrt python from 55 to a later version, and all of these patches from 55 to a later versions. But when it is doing that, it is not able to locate the dependency, the latest version of the dependency in the patch catalog, and that is why it is complaining that I mean, you cannot install a patch without its dependency. So the first thing that I'll do here is I'll check if the patch abrt-libs, and if that patch I mean, if the patch is present in the patch catalog or not. So the version that I'll be looking for is so the install version is 2.1.11-55. So the one that I'll look for is 2.1.11-60. So I believe that's the latest version which is required by dbus and every other patch that is listed here. So I'll just copy this 2.11 thing here, and I'll go to the patch catalog and see if this patch is available in the patch catalog or not. So I'll close this. I'll browse to the depot, the webinar folder, L7, right click on the RPMs, apply filter, copy this patch here, 11, and I think, yeah, 11, and I'll filter here, close this. Let's see what are the patches for abrt-libs here. So we can see that there are all these patches that are listed here. So the 55 is also present here, 57 is also present here, and the 60 patch is also present here. Now, if the 60 patch, I mean the -60 version of the patch is present here, so what could be the reason why this patch is not getting installed by yum update? The other probable reason could be that that there could be an exclude list in the job, which could be I mean, blocking the installation or update of this patch. So let's see the job and see if there was any exclude list being used here or not. So I'll right click and do a show job. So let's go to the remediation, the analysis options, and we can see that there is an exclude list name exclude that's being used. So I'll close this, and I'll go to this exclude list, and I'll see what are the contents of the exclude list. So this exclude list contained all the abrt-libs patch. So the reason for this failure is that there are a lot of patches which are installed on the server which requires abrt-libs as a dependency. When TSSA is trying to update the patch, it is not able to update the dependency because we have specified the dependency in an exclude list. So the other patches are complaining that they are not, I mean, yum is not able to upgrade them because the dependency is missing. So the easiest solution in this case will be to remove the exclude list, or maybe to just have a word with the system administrators to see if they want the exclude list to be in place. Maybe they can look forward and add few other patches in the exclude list as well, because there is no way for those patches to get upgraded if the dependency is a part of exclude list. So you can have a word with the system administrators and see if there is any chance to modify the exclude list. The other scenario could be you remember the first thing that I did was I went to the patch catalog and I checked if the abrt-libs, the greatest version of abrt-libs, which was -60, if that was present in the patch catalog or not. If such patches are not present in the patch catalog, then we have to identify if these patches are coming as a part of some different child channels. Because if you have a patch, an older version of a patch which is which is installed on the server and which is a dependency of some other patch, and the catalog that you created, it does not have the greatest version of the dependency, then the other patches will get failed. So it is somewhat similar to using an exclude list, because Yum will not find that particular patch. In such scenarios, what you need to do is you have to identify what are the child channels, child channel to which that patch belongs to, and we have to add the child channel in the patch catalog and re-update the catalog, run a catalog update job after running the child channel, and make sure that the latest version of the dependency is then added in the patch catalog. Once the latest version of the dependency is added, you run the analysis and everything will be successful. So I'll show you the job right now, which is successful. I have already executed this. I'll just quickly show you that I have removed the exclude list. So I'll just first do a right click and do a show job. So I'll hit the show job. So let's check the analysis option. There is no exclude list. I've removed it. I'll close it. I'll expand this and let's see the target and what are the missing patches. I'll hit on the target server, successful targets, and I'll click on the target here. And you see that these are the missing patches, ABRT, and let's see if ABRT-libs, yes, there it is. It is one of the missing patches right now. So once we fixed the dependency due to the exclude list in this scenario, but in case you're not using an exclude list and the patch is a part of different channel, make sure that the channel is added there. Once you do that, you'll see that the analysis will be executed successfully. So this was how to troubleshoot a Yum dry run error due to a package dependency. Now let's go on to the second troubleshooting problem and see how do we fix those errors as well. We will now see how to troubleshoot the Yum dry run problems due to a multi-lib error. So I have now logged into the console where we can see that this patch analysis job is failed. Let's see what is the error. I'll do a right click and a show log. I'll do a show log. Drill down to the server here. And I'll click on the server, and on the right hand side I see that there is this multi-lib error, and we can see that this is the Yum dry run multi-lib error. That is why the job has got failed here. Now when we talk about the multi-lib error, there could be few reasons why a patch analysis job could fail due to Yum dry run multi-lib error. So now there are three main reasons. A multi-lib error usually points out that there is some problem with the operating system. Now the first cause could be that you have an upgrade for a particular RPM which is missing some dependency that another package is required. Those are the scenarios where where you might get a multi-lib error. The second scenario could be that you have multiple architectures of a particular RPM installed, but Yum can only upgrade either one of those. So that is one of the other scenarios where we can see a multi-lib error. The third problem could be due to a duplicate version. You have the duplicate version of versions of a certain RPM installed. So these are the only three scenarios which can lead to a multi-lib error. More often than not, this is a problem that is related to the operating system. Now let's go to the let's go to the log package and see what is there in the debug logs. So I'll just go to the folder where I have the log package copied here, downloaded, and this is the patch support. This is test2.webinar.com. I'll open the yum.err file here. Now you see that the yum.err file has the multi-lib problem, which is a message from Yum, and at the last we are seeing the RPM name, protected multi-lib versions, libacl, and this i686 is not equal to. So somehow the 64-bit version of libacl does not equal to the 32-bit, which is causing architecture difference leading to a multi-lib error. Now this doesn't tell us a lot that what could be the problem. It definitely gives us some recommendations, but we'll have to log into the server and figure out what the problem is. So let's see, log into the server and see how to troubleshoot this. So the very first thing that we do here, I've logged into the server right now. I'll try to identify what is the version of libacl that is installed on the server. So I'll just run this command rpm-qa grep-i libacl. So I'll see that the version of libacl that is installed is 2.2.51-14. So there is only one version of libacl installed. There is definitely no duplicacy here. The other thing that I mean now uh, in the error there we saw that the problem was with libacl, but there is only one version installed. So the other reason was that the second version could be getting installed due to a dependency or something. So the other thing that we'll have to identify is what are the dependencies or what or of libacl or what patches require libacl. So I'll run the same command that I ran in the previous demonstration, rpm-q-what requires, and this is for libacl. Now I see that there are three patches that require libacl: ACL, libgues, libguestfs, and ACL. So there are two versions of ACL here. .51-14 and .51-15. Now the thing that stands out here is that libacl is one of the dependencies of these three RPMs. So ACL also needs libacl, this version also needs libacl, and this version also needs libacl. And obviously this one also needs libacl as well. But for ACL we can see that -14 is installed already. We can see that this is the version of ACL installed, -14 is installed, which is consistent to the version of libacl that is installed on the server. So we see that the version of ACL is 2.2.51-14 and the version of ACL that is installed here is 2.2.51-14. The version of this patch is 51-15, but the corresponding libacl patch is not installed. So we'll have to verify if the dependency of this particular RPM here is met or not. So what I'm going to do is I'm going to run this command rpm-q R on this RPM just to list out the dependencies of this particular RPM. So if we can see here, where is libacl? Yeah, here it is at the top. We see that this is the version of libacl that is that this RPM needs, which is 2.2.51-15. Now from this command it is obvious that this patch ACL-2.2.51-15 is installed on the server without its dependencies. So there is a corrupted RPM that is installed on the server. So there is definitely some problem on the operating system. So what we usually do in this case, that we know that there is something wrong with the operating system. Even if you run a yum update outside of TSSA, that is going to fail. So the best case scenario here is to involve the system administrators and ask for their opinion how to fix the problem. I mean, this is definitely not a TSSA problem anymore because there is a corrupted RPM installed on the server as well. So the other thing that I told you that I mean, this is an operating system problem, and even if you run a yum update command outside of TSSA, this is going to fail. Now let's try to do that. So now we whenever we run a patch analysis job, be it for Red Hat or Windows or any operating system, the debug logs are stored under this location: OPT, BMC, BladeLogic, RSCD, transactions, and analysis_archive, and there is a job run folder that gets created. So for every run we store the debug logs here. So when we do a download log package, it is actually copying the debug logs from this location. Now if I do ls-la here, we'll see that the contents here are similar to what we saw in the patch support zip file. So we can use these I mean, so the metadata is also here, so we can use these files to run a yum update command and see if we are getting an error outside of TSSA as well. The only thing that we have to do here is we have to modify the yum.conf. So the yum.conf here, it might contain the cache dir and repos dir of the staging area, because these files are initially copied on the staging folder. So what we have to do is we have to change the cache dir and staging dir to the folder where these files are copied. So it needs the this cache dir and repos dir, it needs the address of the folder where you have the metadata. So the metadata we have is in this folder. So what we have to do is, for the cache dir and repos dir, I'll change it to the folder which contains the repo folder. So once I do that, we are good to run the yum update command manually. So the command will be yum-c. I'll specify the custom yum.conf. I don't want to use the operating system's yum.conf, and -C and update. So this yum update command is going to use the TSSA's metadata and going to do a yum on the operating system, which has obviously nothing to do with TSSA. We are running this command manually on the operating system. So let's do a yum update. So it's doing something. It is listing out the patches that it has figured out. So yeah, as we can see that we are also seeing a yum a multi-lib error here as well. So even if I do a yum update outside of TSSA as well, it is giving me a multi-lib error. So this evidence, this is the evidence that there is definitely some problem with the operating system, and in order to fix that, we need to involve the system administrators team. So let's move further and see some of the other troubleshooting scenarios. The next problem that we are going to talk about today is when a Red Hat Linux patch analysis job takes longer time to execute. This can be due to multiple reasons, but the symptom here is that a Red Hat Linux patch analysis job takes longer time to execute when an include exclude list is used. But without any include exclude list, the job is pretty fast. We will see how to optimize the include list to improve the performance. I have now logged into the console. I'll just show you the log here where we see that the job is slow. I'll do a show log. So as we can see that the patch analysis job against this server test1.webinar.com is successful. But if you look at the start and the end time, it took almost for 50 minutes for the job to complete against one target, which is which is pretty bad. So we'll see if any include exclude list is used in the job. So I'll close this. I'll do a show job. I'll go to the analysis option and we can see that there is an include list that is being used here. Now when an include list is used here, the number of patches in the include list are passed as an argument to the Linux analyzer script, which can take a longer time to execute. We can trim down these arguments significantly by using the by package name only option. So let's see how we can select that option. I'll close this. I'll go to the problem 3 here, which is the job. Go to the analysis options and I'll just arrange this, and yeah, so you can see there the include exclude list options. There are two options, by package name only option and by complete package name. So the default option that is selected in any patch analysis job is by complete package name, and when you use any include exclude list with the by complete package name only option, the patch analysis can take longer time. By using the other option, which is the by package name only option, when we use this use this option, the argument list is significantly smaller because we are not using the complete package name along with the version. We are just using the package name only. So suppose if any RPM, there are 5 versions, version 1, 2, 3, 4, 5 present in the catalog. So instead of listing all the versions one by one, we are just using the package name, and when yum is running an update against the server, the missing patch is only the greatest patch. So we are always getting the greatest patch being reported as missing, but the option by package name only, it trims down the include list. Now that does not affect the patch analysis result, as only the latest and greatest patch is being reported as missing. The best practice, as a best practice, BMC recommends to use the by package name only option in an analysis when an include exclude list is being used. So I'll show you the results where the job was fast. I'll just do a right click here. I'll hit show job. So let's go to the analysis options. You can see that I'm using the same include list, and in the include exclude list options, I am using the by package name only option. So let's see the job run results and see how long did this run take. I'll close this, right click, and I'll do a show log. I'll hit the show log here. So as we can see that the patch analysis is successful here, but the analysis actually took 8 minutes. So we can see that the by package name only option reduces the execution time significantly, and hence the performance is better. In this problem, we'll focus on Redhat 8 patch analysis job. The job fails with the error shown here, error while loading shared libraries, lib nsl.so.1 cannot open the shared object. Now this error is caused when the system does not have the lib nsl installed. In earlier versions of Red Hat, the lib nsl.so.1 file was a part of glibc RPM. In Red Hat 8, the file was moved to its own RPM. So let's log into the console and see the error. So as we can see here, the job has failed. I'll do a right click and do a show log. So I'll click on the server name here, and we can see that the job has failed, and this is the error while loading shared library lib nsl.so.1. The solution here is to install the lib nsl rpm. So I have already installed it on my Red Hat 8 server. I'll just show it to you. So this is how that I have installed this RPM on this server. So once this RPM is installed, if you run the patch analysis, it will be successful. So I'll show you a successful run here. I have already executed the job. I'll close it. I'll expand this, right click here, do a show log, and we can see that the job is successful here. So this is a prerequisite for Red Hat 8 that the lib nsl rpm must be installed on the server. This prerequisite has also been mentioned in the official BMC documentations as well. We will now talk about the TSSA Red Hat Linux patch remediation job. This is the process of packaging and deploying to target requiring remediation. The necessary BL packages and deploy jobs are created for targets identified in the analysis phase. There are 3 phases of a TSSA deploy job. Simulate. This checks the basic connectivity and job options. Stage. Patches are copied from the repository server to managed servers in this phase. Commit. Patches are installed on the managed server in this phase. Creating a remediation job is similar to how we do it for Windows operating system and other operating system. Let us now see how to troubleshoot when a patch remediation job fails to deploy patches on a target server. So the problem that we are going to see here is that a patch remediation job fails in commit, complaining that there is not enough space in the boot file system on the target server. I have now logged into the console, and we can see that there is a patch remediation job which has failed on test2.webinar.com. As we can see that the job has failed in commit stage. So let us click on commit and see what is the error. So as we can see below here, there are a lot of errors, and from the logs it seems that the error here is related to the available space on the /boot file system. As we can see here, it is trying to install kernel patches, and it seems that there is not enough space on the target server. So this is the error in the job run log. So let us see what are the logs that get updated on the target server if a job fails in the commit in the remediation phase. So I'll log into the target server. So this is the target server that we used in the job. So when a remediation job fails, typically we check for the BL deploy logs on the target server. So the BL deploy logs on a Linux server are on OPT, BMC, BladeLogic, RSCD, transactions, and log folder. For every remediation and deploy run, we create a unique BL deploy log. So this is the BL deploy log that was created for this particular run. Now whenever we are troubleshooting any remediation failures, BL deploy logs are very important. Apart from these logs, we can sometimes there are meaningful errors in the job run logs or the application server logs. So while troubleshooting any remediation or deploy failure, the logs that we are going to collect are job run logs, the application server logs, and RSCD logs from the target servers. And apart from that, we'll also check the BL deploy and the BL target job manager log. So these are the BL deploy logs on the target server. I have copied it on my local desktop, and I'll open it on Notepad. So this is the BL deploy log that I've copied from the server, and as we can see here, this is the error here. So the error is transaction check error, and it is trying to install kernel patches, and there is not enough space on the /boot file system. So let's check what is the space, available space on /boot file system. So this is the /boot file system, and the total size is 488 MB, which is normal for Red Hat servers, and the available space is 223 MB. Now if I check the logs here, it is complaining about that it needs at least 144 MB of free space on /boot file system. Now whenever a kernel patch is installed on any Linux server, the kernel patch is installed inside /boot file system. Now if there is not enough space on that particular file system, the system administrators might have might have to remove some of may have to remove some of the older kernels on the servers that are not being used to free up the space. But this I mean the problem in this particular scenario is that the TSSA patch deploy job is trying to install more than one kernel. So the expectation is that whatever is the latest kernel that is present on the catalog, that should be installed on the server. But it seems that it is the job here is installing 5 kernels on the system. So it's obvious that with 488 MB of free space, the /boot file system will not be enough to accommodate all the 5 kernels here. So the problem is not with the space on /boot file system. The problem here is that why the patch analysis job is reporting 5 patches as missing, and that's why we are trying to install it. So let's go back to the console and see what is the result during the analysis. So this is the analysis run. I'll expand it. I'll go to server view here, successful target, and this is the target server. Now let's check for the kernel patches. Now we can see here that there are 1, 2, 3, 4. See, there are a lot of kernel patches that are being reported as missing here. Now the expectation is that we should only report the latest kernel as missing. Now the reason why the TSSA patch analysis job is reporting multiple versions of the kernel RPM as missing is because there is an include list that is being used, and in the include list all the kernels are being listed as the include list contain all these version of kernel RPMs. So if that happens, the TSSA patch analysis job is going to report all the kernel patches as missing. This is not true for the other patches. For the other patches, it will only show the latest version, but when an include list is used with all the kernel versions, it usually reports all the version as missing. Now let's see what are the options that are selected in the patching job in this particular field run. So I'll do a right click here and do a show job. I'll click on the show job here. So let's check the analysis options. So in the analysis options, we can see that there is an include list that is specified. The name is kernel. It has all the kernel RPMs. Now if we check the include exclude options, the option that is selected here is by complete package name. Now whenever an include list is used with multiple kernel RPMs and the complete package name is this particular option is selected, the TSSA patch analysis job is going to show all the kernel RPMs as missing, and then the remediation job will try to install it. So the fix for this particular scenario, this particular problem will be to use the other option that we saw during the analysis by complete package name. So I have changed this option and executed the job again with the package name only option. Let's see what are the results there. So I'll close this. So this is the run that is successful here. I'll quickly show you the analysis here and successful targets. I'll click on this test 2.webinar server here. Yeah, And if we see here, there is only one kernel patch that is being reported as missing, which is the latest one only, and due to which the remediation job is successful, because it is only installing one kernel RPM, and 223 MB is good enough space to accommodate one kernel. So I'll show you the options that I've used in this job here. So I'll do a right click, show job. Let's check the analysis options. So as you can see here, for the successful run, the analysis option that I have selected here is by package name only. So this is one of the cases where the patch remediation job failed while installing kernel RPMs, because one or more than one RPMs were getting installed on the server due to an include list was being used in the patch analysis job with the complete package name option. So this is one of the other advantages of the by package name option, wherein in case you notice that during a deploy or remediation or deploy, multiple versions of a certain patch are getting installed, check the include list if there is there is an include list that is in use, and the option that is used is by complete package name. The solution in this scenario will be to use the package name only option. Now these are this is one of the most common error that we encounter during commit phase. So in case there is some other errors due to which you see that the commit is failing, in order to troubleshoot, as I stated earlier, the logs that are required are the job run logs, the application server logs, the BL deploy and the BL target job manager log from the target server, and the RSCD logs from the target server. This brings us to the end of the demonstration. I would like to take a moment to introduce you to some of the self-help content. BMC Support has created several troubleshooting guides. Look for the troubleshooting section at the top level. These guides are based on commonly raised support issues. Some of the problems that I have talked about in this demonstration are also explained in the troubleshooting guides. These are the links to some of the documentations that I have referred in the demonstration. We also have a link to the Redhat patching playlist that we have on our YouTube channel. Please subscribe to our channel to never miss an update whenever new content is uploaded. This brings us to the end of the webinar today. We talked about the steps involved to patch a Red Hat server in TSSA, which are a patch catalog update job, a patch analysis job, and a patch remediation job. Thank you all for taking out time from your busy schedules and joining us for this webinar today. Over to you, Greg. Thank you.
Thank you. And now I'll take us through the self-help in contacting BMC. The YouTube channel where this webinar will be posted is available at this link. It contains past webinars as well as a rich set of how-to videos. The Connect with Truesight webinar schedule that contains future webinars as well as our past webinars is available at this communities link. Also, the Hot Off the Press newsletter contains trending information. And to contact technical support via web, phone, email, as well as these social channels are available through these links. That will conclude our session today. Thank you for attending.